Okay, so chapter 7, like I said, we're going to begin talking about area between curves today. So I'm just going to start out with an example before rather jumping into a definition. So let's pretend that I have a curve, and here's my x and y axis. And let's say that I have a curve that looks like that. I'm going to call that f of x. You okay with that? And then I'm going to have an interval from A to B. Yes? You okay with that? Mm-hmm. On your paper, using calculus, tell me how you would find the area under the curve for f of x. So on your paper, guys, on your paper, write down how you would find the area underneath the curve of f of x between A and B. Alright, so I'm going to assume you got it. So area is equal to the definite integral from A to B of f of x dx. Is that what you got? That would represent, and I'm going to highlight it here, and I'm going to try to make it as least confusing as possible with using different colors. That will get you that, right? Yes? Okay, now I'm going to pretend, and I want you to pretend that this is a blank coordinate plane. Okay? Like this is not on it. You're with me? And in red, or in a different color, I'm going to sketch a different curve. I'm going to sketch this curve right here, and that's g of x. Cool? That would mean that the area under the curve would be this right here. Agreed? How would I do that with calculus? Integral from A to B of g of x dx. Right? Easy? Switch colors one more time. Now I have them both in there. You're with me? I have them both in there. I know there's two pieces of information, right? But here's what I really wanted from the beginning. I just want to know how much that area is in green. Any thoughts or any guess of what you can do to figure out? Subtract what? Use color. Subtract what from what?
Blue minus red.
Subtract the red from the blue? Yes. Do you guys agree? Because the blue represents everything from here all the way to the x-axis, right? So if I take away the red, I should just be left with the green, right? So can I write a statement what the area of the green is? Yeah. What is it? The blue minus red. Well, like give me a statement. A to B of f of x minus g of x dx. You can write them as a separate integrals, but we can use our properties, and remember, we can just combine it into one. And that's what we're doing today. Do you understand where it comes from? Like, you need to know this formula right here, but I want to make sure that you understand where it comes from. Do you understand where it comes from? Yes. Because if you understand it, it's a lot easier than just memorizing it. Does it make sense to you? Yes. Okay. Now, I got to give you the actual definition of this thing. And I think you can come up with it. Because every single definition I've given you in calculus has like that one requirement. If f of x and g of x are continuous, for sure, continuous from A to B. Okay? If f of x and g of x are continuous from A to B, and one more thing, in order for specifically for these examples, I'm going to use this example, g of x has to be less than or equal to f of x. Agreed? It can't be above it. Like, is g of x below f of x? We'll talk about that here in a little bit. From A, like, read the definition, from A to B. Is from A to B, g of x always below f of x? Yes. If f of x are continuous on that interval, check. Yes, continuous, check. On the same interval, is g of x less than or equal to f of x? Then this is true. You with me? Does it make sense? Yes? Yes, sir. Oh, you sure? Okay. All right. So we're going to try several examples doing just finding area between the curves. But before we get there, I always have this problem that students question a lot, and I'm going to try my best to explain it to you. When you were doing definite integrals, you learned that area underneath the x-axis is subtracted, right? Agreed? Well, let's talk about it, and hopefully I'm going to do an example so maybe you understand how that's not going to be the case between two curves. Okay? So I'm going to do my best to explain it to you. So let's say I give you the following example. So once again, I'm just going to use pictures to help you out. Let's say that you have this graph. Let's call that f of x. And then let's say that you also have this other graph. And let's call that g of x. Cool? And we're still going to go from a certain interval. So let's call this a and let's call this b. You with me? Could you find the area between these two curves? Yes. Based on what you learned? Yes? Now, I'm going to digress in time like a lot. And I'm going to pretend you still don't know how to use integration to find area. So we're going to go back to Riemann sums for a moment. So I'm going to create a rectangle. So I'm going to create a rectangle right here. Cool? I'm going to call the width of that dx. You should understand why. Right? Change in x. Right? Now, let's just make up some numbers. Let's pretend that this value right here, so it's about right there. I'll make up a value, so here, just a number. 5. Okay. And then let's make up a value up here. Give me another one. 8. Cool. Which means then that the distance here is what? 3. So that means that the area of that little rectangle is what? 3dx. Do you guys agree? Yes? Everything's above the x-axis. Everything goes according to what you know, right? It should be positive. We're good. Agreed? Okay. Here's what I want you to try to do, but we're going to do it together. I'm going to take that same graph that we have there, but I'm going to do a transformation to it. I want to take this graph and move it down 7 units. The entire thing. 7 down. 7 units down. So if I do that, what would be the equation of g of x? G of x minus 7. Do you agree that at that point, if you do minus 7, you are going to be below the x-axis? Yes. So I'm going to do my best approximation. I'm going to say that this is what it looks like. Okay? So this is g of x minus 7. Yes? Now, f of x also has to come down. Agreed? But is it going to be above the x-axis? Yeah. A little bit above the x-axis, right? So right there. You with me? And this is f of x minus 7. Are you guys still with me? So I'm going to use the same intervals. So I'm going to say from A to B. Now, I know I didn't sketch it the most perfectly that I could, but I'm doing my best here. Okay? That little rectangle is still with me, right? It didn't change size. Do you guys agree? Like, the little rectangle is still d of x, right? And 3. So the area is what? But I'm below the x-axis. What do you mean? Well, you're between two curves. It doesn't change the area. Okay? It's like, there it is with a picture, like I'm proving it to you. It's not changing. Just because I'm below the x-axis doesn't mean I'm like a negative area. Okay? I'm between two curves. Question. I don't really want to draw this again. What if I put the entire thing underneath the x-axis? It would still be the same rectangle with the same delta x and the same height, being that the area will be 3dx. So I want to make sure and be very clear before we get started. if your curve happens to be underneath the x-axis and if we're finding area between two curves, do not make it into a negative area. Understood? Because we're talking about area between two curves. Understood? Alright, so are we ready then to tackle a few problems? Alright, what we're going to try to do here on this video is we're going to do it by hand first, and then you're going to use a calculator to check your answer. Cool? Alright, so let's go ahead and tackle the first problem now. Example number 1. We want to, first and foremost, I want you to sketch the region. And I recommend that you do this every single time. This is the first time for pretty much all of you guys to try this. Those of you that took AB, if you don't want to draw the sketch, it's fine. You've had practice with this. But for now, this is still a very new skill for you. Sketch everything. Okay? So I'm going to give you two functions. The first function I'm going to give you is f of x equals to negative 2/3 x times x minus 6. The second function is g of x is equal to negative 1/2 x plus 11. The third function is x equals 0. And the fourth function is, well, it's not even a function, sorry. The third equation is x equals 0. And the fourth equation is x equals 6. Right? Before we do anything calculus, if you're watching this video, go ahead and pause it and give me a rough sketch. It doesn't have to be exact. Just give me a rough sketch of what this looks like. Okay? Now, before I hit pause, I wrote it this way to help you out. This is a parabola, right? It's a quadratic. This should help you find the zeros, and that should make it easier to sketch. If you know where the zeros are, the vertex is going to be right in between that, and you can figure out what the vertex is. Okay? So try that. Alright, so hopefully you got a sketch that looks something like this. Really, the sketch is to help you get started with the calculus of this. You know which function is bigger than the other, and that's going to help you. Also, the sketch is going to help you know from where to where you're trying to find area. Yes, sir?
Wouldn't the vertex be at 6?
You have a 0 at 6.
No, y equals 6? No, I want 3. I don't believe it.
3 minus 6 is negative 3. Oh, so it's 6.
Right.
God, thank you. Thank you.
The vertex has changed.
6. Alright, so totally my sketch now makes more sense. Look at that. Alright. Alright, so here's what we need to do. We need to find the area between the two curves. Alright? So we need to set up an integral. So area of this thing is going to be equal to the integral from where to where? Let's start there.
The integral of negative
From 0 to 6, right? Because you were given these boundaries, right? So from 0 to 6 of what?
negative 1/2 plus x
Negative 1/2 x plus 11
minus
minus
Or plus 2/3 x minus x minus 6.
Yes, you can do all the algebra here in just a second, right? Agreed? I'm just going to leave it in this so you can see how, like, I'm just literally substituting stuff in, right? It's the top function minus the bottom function, right? Now, I got to be completely honest with you. You need to know how to do this. You don't need my help.
We don't.
Pause the video if you're watching this and solve this. Go. Alright, so I'm assuming you've already tried this problem on your own. Honestly, what I did first before beginning to integrate, I used a little algebra to kind of clean things up to help me out later on as I'm integrating. So once I clean things up, the integration looks like this. I'm going to evaluate from 0 to 6. When I saw that 0, I was very happy because things were just canceling out, right? Really, just check your algebra and make sure that you're able to get 33. Okay, so the answer is that the area under between these two curves is 33. Units squared. Very good.
Wait, so what's the integral?
Alright, we're going to go ahead and move on to our second example of today. So example number 2. And we're doing the same thing. We're going to find the area under the curve. But here's your equations. Negative 4x plus y equals to 12. Y equals x to the third power plus 3x squared. Alright, I want to do this problem completely on the calculator. Not that you can't handle it by hand, it's just the numbers are too big. Okay? So, I'm going to go ahead and grab my calculator and get a representation of what this looks like. If you want to do it, sure. I'm just trying to show you how we would do it on the calculator, like the problem completely. Okay? Alright, so the first thing we're going to attempt to do here is make sure that we can solve the first one for y. Agreed? So it's y equals 12 plus 4x, and y equals x to the third power plus 3x squared. Yes? Alright, so I'm going to go into y equals, and we are going to sketch this. So 12 plus 4x, and then x to the third power plus 3x squared. I'm going to type that in. I'm going to hit graph and see what it looks like. Okay. Did you guys notice that between the last example to this one, the last example I told you to go from 0 to 6. But this time I didn't tell you where to go from where to where. I said find the area between the curves. Do you see how you have area between the curves? If you don't see it, I'm going to have to manipulate this so you can see it a little bit. So I'm going to hit zoom. Let's see. Let's go decimal so maybe you'll see it. Okay. Do you see how the curves are enclosing this little area here? We need to figure out what that is. So I'm going to mess with my window a little bit. So I'm going to go Y max. I don't know. I'm going to go to 6. Hit graph. Okay, do you see that little area in between? Yes? I need to figure out what that is. So, the first thing I'm going to do is I need to figure out where they are intersecting. And with the calculator, you do second calc, and we're going to calculate the intersection, so number 5. So I'm going to just hit enter, enter, and then I'm going to move this to, let's figure out that intersection. So it's intersecting at negative 2, 4. Cool? Alright, so I'm going to kind of write that down so I can remember. So negative 2, 4. Now I also got to find the next intersection. So intersection is down here. Honestly, you shouldn't even need to find this one. It looks like it's at negative 3, 0. Right? Okay. So here's where I'm going to begin then to find this problem. I know that the area is going to be the integral from where to where based on this information. Negative 3, negative 2. Of what? Well, which one of this is the top function? So which one is the top? The cube, right? So it's going to be x to the third power plus 3x squared minus what? 4x plus 12. I understand what you're doing. It's okay. Alright? You guys with me? Now, I should be able to use my calculator to figure that out. Agreed? Question. I think I'm missing something.
Yeah, because if you zoom out, it'll intersect again.
I'm going to zoom, so I'm going to hit window. I'm going to really go out there. So I don't know, let me make my maximum like 30 or something. Oh. That wasn't the only part that was enclosed. I also have this part that's being enclosed. Yes? So I already know that this point right here is negative 2, positive 4, right? I just need to figure out what this point right here is. You with me? So I'm going to do second calc. I need to find the intersect. So enter, enter, and enter. 220. Right? So that means, hey, not only do I have this area right here, but I also need to add the area that's right here in between these two, right? From where to where?
From negative 2 to 2.
Negative 2 to positive 2. Very good. But what else do you notice happens when you reach that x equals negative 2.
The
The
line
other
comes
line
on top.
becomes on top.
Exactly, they switch. So now, what is this integral going to look like?
4x plus 12 minus x cubed
4x plus 12 minus x cubed plus 3x squared dx. Yes? Now, again, could you do this by hand? Absolutely. For time's sake, let's use the calculator, and that gives me the advantage to show our viewers how to do it. Cool? So I'm going to do it on the calculator completely. I'm going to say alpha window, and I'm going to go down to option number 4. That allows you to do a definite integral. So I'm going to hit enter. And I'm going to type the first one. So the first one's from negative 3 to negative 2. And I'm going to type it exactly what it looks like. Okay, make my life easier. So I'm going to say parentheses x to the third power plus 3x squared, close parentheses, minus 4x plus 12. So minus parentheses 4x plus 12, close the parentheses, and this is in terms of x. And you don't have to do them separately. You can put it together. Plus, and I can do another integral, and I'm going to go from negative 2 to 2, and this time it's switched off. So parentheses 4x plus 12 minus parentheses x to the third power plus 3x squared. Close the parentheses. This one's also in terms of x. And I'm going to hit enter. And our area is 32.75.
The sign doesn't get split
What do you mean?
because the equation that was on top changed. I thought it would maybe become negative.
No, I mean, it's still the same equation, right? Like, you didn't change anything. Like, it's still, it just happens to be on top after that negative 2.
Yeah.
Cool? Questions? Alright, if you are watching the video and you really want to try it by hand, you're welcome to try it. It's good practice. It's not a difficult problem. It's just the algebra gets a little messy. Alright, moving on to our next example. Example number 3. We're going to do y equals x plus 1. Y squared equals to 2x plus 10. So once again, we are interested on finding the area bounded between the two regions. So we need to sketch this out. Okay, so I'm going to go ahead and start sketching this out. So let's do this one together. So here's my x and y axis. Is the second one a function?
No.
It's not. What is it? It's a what?
Oh, y squared.
It's a parabola that's opening left and right, agreed? Either left or right. Right? So it's a conic.
Oh.
Yes, because it's not a function. It fails the vertical line test. It's not a function. It's a parabola, it's a conic. It's opening to the right because it's positive. But it's okay. You can figure it out. So let's do this. The very first one you have no problem graphing, x plus 1. So you have y-intercept of 1 with a slope of 1. So it looks something like that. Alright, I agree with you. So if you don't remember how to graph the conic, then what I would do is I would rewrite this as y equals to plus or minus the square root of 2x plus 10. Do you understand why the plus or minus? Take the square root of it, you need a positive and a negative, right? Now, the moment I saw that, I actually pretty relieved because technically this has the parent function of square root of x. And the parent function of square root of x looks something like that. Agreed? So I know this thing is going to look that, which you kind of expected that. You had a parabola, right? So it will move to the left 5. How do you know that? Well, you can factor out this 2, and then it leaves you with a 5, and according to your transformation, it moves to the left 5. So instead of being at 0, 0, you're left 5. So 1, 2, 3, 4, 5. The more algebra you know, the easier this becomes. Let's say you don't remember that. How could you figure that out? Well, we can set it equal to 0, right? We can say square root of 2x plus 10 is equal to 0. which means that if we square things, we get 2x plus 10 equals to 0. 2x equals to negative 10. X equals to negative 5. And indeed, that's where we're at. Yes? Now, just to help ourselves out, we could also figure out what value is on the y-axis by simply plugging in 0. 2 times 0 is 0 plus 10 is square root of 10, which is a little bit more than 3, right? So 1, 2, 3, let's say I'm about right there. And again, I'm just doing a rough sketch. So then it looks like this, right? Now, if you only graph the positive, nothing is being enclosed. Agreed? You got to remember you have a negative of this. So it looks exactly the same, but going the opposite direction. So like that. Now it's very obvious that we're enclosing this area right here. Yes? Question. If we're enclosing that area, we need certain values. We need to figure out certain values. Agreed? We for sure know that this one's negative 5, 0. Yes? We need to figure out what this point is right here. Agreed? Good. So we don't have a calculator. We're going to have to set them equal to each other. Agreed? So what would that look like for this problem?
X plus 1 squared.
So I'm going to plug this entire thing into there. So I'm going to say x plus 1 squared is equal to 2x plus 10. Yes? Okay? X squared plus 2x plus 1 is equal to 2x plus 10. The two x's are going to cancel out. If I subtract 1, I get that x squared is equal to 9, so x is equal to plus or minus 3. Yes? Now, based on the location of this, this is the point 3. So this is going to be 3 comma something. How can you figure out what that something is? Plug it in. And if I were you, I would plug it into the easier equation, which is this one, right? So it's a 4. Agreed? Yes? Okay, so we have the point negative 5, 0 and the point 3, 4. What do you guys think? So we need to find the area between these two curves.
Shouldn't we also find where the other point intersects?
Why do you want to know this one? Okay, so then my question is then, how do we go from here then? We got those points, now what?
Maybe you separate it so that way you do like the top one first and then do the bottom.
I think when you read what Jada said, you take that point and you move back to that point and then from that point to the
Why do we need to do that? You guys are correct. So I didn't say you were wrong. I was just asking why. You are correct. Like, we do need to figure out this point. Now, if you didn't hear in the back what they were saying, they were like, hey, why don't you split this into two integrals? An integral that goes from here to this point, and then an integral that goes from here to there. Why do I need to? Like, I have to do that. Why do I have to do that?
Oh, because at the bottom is at the top.
The bottom is at the top.
The bottom part and then it turns into a different.
Okay, look.
Yeah.
I'm going to start from the right this time. Is it obvious here that this is on top and this is on bottom?
Yeah.
Top, bottom, top, bottom, top, bottom, top, bottom. But then I get here, it's no longer the same bottom, per se. It's not the same bottom function anymore. Do you guys agree? Now the bottom function is the negative component of this. You're with me? This is why I suggest that you sketch things out and don't try to like just plug numbers and think like, oh, this is on top of the other, so this one's on top. Because you don't know what's happening throughout the entire domain. Okay? Sketch things out. Don't try to save yourself a minute and then miss the problem because it happens to be that at some point then switched. Okay? So we're going to have to do two different integrals, which means that we do need to figure out what this point is. Well, how am I going to figure that out? Well, we already know that it's negative 3. So it's negative 3, negative 2. Yes? Agreed? Okay, so I'm going to use red to represent this right here. You with me? Okay, so the red is going to be area equals the integral from where to where? Negative 5 is the x values to negative 3. What is the top function? So square root of 2x
10.
plus 10 minus what is the bottom function? Negative of the square root of 2x plus 10. Good. Dx. Yes? That's going to get us the area in the red. Now, what's going to get us the area in the blue? So plus integral of what? Negative 3 to 3 of what? Square root of 2x plus 10 minus x plus 1 dx. Yes? Now I'm going to take one more step with you because I want to explain something before I let you try this on your own. When you start simplifying things out here on the red example here, do you notice that minus and minus is plus, which makes it that you have two of the same, so you technically have two of the same thing? Question, could you have saved yourself some work and realized that from the beginning, that since this is a parabola, this area right here, so I'm going to try to use a different color, I'm running out of colors, this green right here, just there, is the same thing as the bottom there? So could you have just done your previous knowledge from like chapter 5, from negative 5 to 3 of just the top, and then multiply by 2, which actually ends up being the same thing? Just kind of throwing that out there. Cool? Alright, so we can do that. And then here, again, I would simplify things to make your life easier. So plus the integral between negative 3 to 3 of the square root of 2x plus 10 minus x minus 1 dx. Now, at this point, I want you to go ahead and pause the video and try this on your own. Yes, sir?
Like, dx is respect to x, right?
Correct.
So, like, for the square root,
We're going there next.
oh, okay.
Try this on your own. Alright, I'm assuming you've already tried this. Here in my class, we seem to have an issue with our algebra skills. That's really what seems to be the problem,
I got 18.
I hope. With the calculus, I want here to the side to make sure, like, you remember how to integrate just by itself, like the square root of 2x plus 10. So if you integrate it, it becomes a 1/3 2x plus 10 to the third to the 3/2 power. So I use that throughout the problem to help me out with the integration. So I know I have the 2, so when I multiply it in, I can get the 2/3. I'm going to have to evaluate it between negative 5 and negative 3. Once again, by me integrating on this side, it helped me out here. You should have no problem integrating the x, the negative x, and the negative 1. So that's negative x squared over 2 and then the negative x. We're going to evaluate between negative 3 and 3. I didn't show every single little step, as you can see, and as Zach kindly pointed out to everyone, I made mistakes. Really, here's the fractions that you end up getting when you plug in the values, and when you combine them, you should get 18 units squared. Yes, ma'am?
Where, doesn't the two go away though when you use them?
No, because there's a half.
Because
Or
of
yeah.
the half, yes, the 2 go away because of the half, but look, let me kind of go back to when you integrate just this by itself, right? So you let that be u, so when you take the u, you get 2 dx, right? So we're going to rewrite it as, I'm going to divide by 2, so that's why I have the 1/2 on the outside. So I have the 1/2 u to the 1/2 power. But when I integrate that, I add 1, so I get 3/2, and I divide by that, which I get 2/3.
Kind of spooky that.
So 1/2 times 2/3 cancels that out, leaving you with the 1/3.
Okay.
So then when we bring it back to our real problem, we can multiply by 2, so it becomes a 2/3.
Okay.
Cool? Alright. Other than the algebra, are we okay with the concept of finding the area between the two curves? Yes? Alright. That was too much work for one simple problem, in my opinion. Okay? Let's go back to this.
Oh, yeah.
This is what it looks like. Okay? Now, Pranav, tell us what you were going to say like 10 minutes ago or so.
So, like, so normally y equals x squared is a parabola facing up, but then y squared equals x is a parabola facing the side, which is what we have. So when you integrate, you have dx, which is telling you it's the area between the graph in the x-axis.
Okay, good. So far what we've done is we've been finding area using the x-axis, dx in terms of x. What do you suggest?
So then, like, since it's a parabola facing towards the y-axis, you could just find the distance between the parabola and the y-axis.
Okay, look how I labeled everything. This is still my y-axis and this is still my x-axis, right? Could you tell, like that, which one's on top and which one's on bottom through the entire range of values? Yes? Through the entire process, the line is on top and the parabola is on bottom. So why don't we just integrate with respect to, now look at this, this is what? The y-axis. So why don't we just integrate with respect to the y-axis? Well, let's do it. Now, there's a few changes you're going to have to make in order to make that happen. So I'm going to go ahead and flip the page. Remember that you had your equation as y equals x plus 1 and y squared equals to 2x plus 10. Yes? In order for you to use integration with respect to y, you need to solve both equations for x so that they are in terms of y. So the first equation would be x equals to what? Y minus 1. And the second equation would be what? Y squared minus 10 over 2 equals 2x. And I can clean it up a little bit by saying that is 1/2 y squared minus 5 is equal to x. You guys agree? Yes? Now I'm going to go back to the sketch one more time so I can show you again what's going to happen. So because we are integrating with respect to the y-axis, that means I need this value right here. I'm going from here to here, right? But that's the y values. What are those y values? 4 and negative 2. So when I write my integral, I'm going to say this is the area between negative 2 to 4. Which one was the top equation the entire time? The line. So it's going to be y minus 1 minus 1/2 y squared minus 5 dy. So we clean this up a little bit. So it's the area between negative 2 to 4. Okay, for sure it's going to be negative 1/2 y squared. Agreed? We're going to have plus y. And then I'm going to have negative 1 plus 5, which is, so the subtraction.
Oh, that's not the antiderivative.
I'm not, I'm just rewriting it so I can do the antiderivative. You guys with me so far? Okay, antiderivative y, so area equals 2. I'm going to do to the third power, so what does this become? So negative y to the third power over 6, right? Plus y squared over 2 plus 4y evaluated from negative 2 to 4. Yes? Agreed? Okay. Area equals, okay, what's 4 to the third power? 64. You guys agree? Over 6. (32/3). Yes? 32/3. Yes? So it's going to be negative 32/3. Yes? Plus, what's 4 squared? 16. Divided by 2? 8. Plus 16. Yes? Okay. Minus. Alright, what's negative 2 cubed? Negative 8, but it's a negative, so it becomes positive 8, right? 8/6 is the same thing as 4/3. Negative 2 squared is divided by 2, so plus 2. Negative 2 times positive 4 is negative 8. Area equals, okay, so for sure we have 24, right? But if we get that in terms of thirds, what is that? 24 times 3. 72, very good, over 3. Minus, okay, right here we have negative 6, right? In terms of thirds, what are we talking about? 18, right? Cool. Area equals, alright, what's 72 minus 32? So it's 40 over 3, right? Minus, okay,
14 over 3.
negative 14 over 3, right?
54 over 3, which
54 over 3, which
is 18.
is 18 units squared, which is exactly what we obtained using the other method. Agreed? Could you use either method? Absolutely. Which one was easier?
The second one.
With respect to why? So sometimes you're going to have to analyze the situation and apply what your judgment tells you is the best route for your skills at that point. If you don't feel very comfortable doing in terms of y, it's okay. You can still do it in terms of x, but it requires a little bit more work. Okay? Any questions about this example?
How do you know when, like, what's the best way to switch to the UI?
You have to graph it and then use your judgment there to determine what you think will be better for you at that point. Okay? Alright, I technically have a couple more examples, but I'm going to be honest, it's been a long class today. I think you get the main idea, which is one of them has to be on top, one of them has to be on bottom. Okay, and you use subtraction. The homework is on the calendar.
We're gonna check it.
Thank you for watching.
Like and subscribe.